You use your smartphone every single day. You tap it, you scroll it, you turn it up, you turn it off. And yet, almost no one knows how it actually works on the inside. That is not a failure. That is the entire point. Today, we uncover the two ideas that make it possible: abstraction and decomposition. Consider a smartphone. For most people, a phone is a black box. We understand it purely in terms of its inputs and its outputs. The phone has buttons. You can scroll and you can touch things. But we do not know exactly how the buttons, the scrolling, and the internal workings actually do their job. And here is the key. We do not need to know. As users, all we care about is the interface between us and the task we want to achieve. That interface is simply the relationship between the input we give and the output we get back. Push one button, the phone turns off. Push another, and the volume goes up. That relationship between input and output, with everything else hidden, is the idea of abstraction. The phone abstracts away all of the hardware, all of the details and implementations that make it work, and hands you a clean, simple interface instead. Notice what abstraction is not. It is not vagueness. The interface is precise. This input produces that output every time. What gets hidden is only the how, never the what. The user does not need to understand the internals in order to use the device, hide the complexity, expose a simple contract. That is abstraction. Here is where abstraction pays off. Once the details are hidden behind interfaces, abstraction enables decomposition. Think about who actually builds a phone. It is not one company making every single piece. Different manufacturers work separately on different components. One team builds the screen, another builds the battery, another the camera, the processor, the speaker. Hundreds of distinct parts built independently, often by companies that never even speak to each other. Decomposition is exactly this: splitting one big system into separate, self-contained parts that can each be built on their own. But hundreds of independently built parts still have to fit back together. They do it through specifications. Each manufacturer follows a specification for their component, a fixed set of inputs that come in, and a fixed set of outputs it must hand to the other components. That specification is the interface, and it is all any manufacturer needs. The camera team does not need to know how the processor is built. They only need to know what it provides. And because the interfaces are standardized, every part can be brought together and simply work. So decomposition is not chopping a system into random pieces. The pieces are joined by agreed, standardized interfaces, so they lock back into a working whole, all aimed at one common goal: making the phone work. Now for the payoff, because this is true for hardware, and it is just as true for software. In programming, we suppress details in exactly the way the phone does, using abstraction. We write a piece of code with the intention that it will be written only once, a self-contained piece that does one genuinely useful task. We write it, we debug it, we make sure it works well, and from that moment on, we treat that code as a black box. As long as we know what inputs it needs and what outputs it gives back, we no longer care how it does its job. We only care that it is there, ready to use. Once it is written, we can reuse it ourselves or hand it to other people so they can use it too. So two ideas carry us all the way from a phone to a program. Abstraction: treat something as a black box, hide the how, and expose a simple interface of inputs and outputs. And decomposition: split a large system into independent parts joined by standardized specifications so they fit together into a working whole. This is exactly what we are about to do in code. The tool that gives us both at once, letting us write a useful piece once, seal it as a black box, and reuse it anywhere, is the function. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.